Friends, welcome back to my channel. In this session, I created a project. This is a battery monitoring circuit and it will control the charging and discharging level of the battery. For example, this is a battery simulator. When the battery is reaching at 13.4 volt, this time the battery is charging. This relay is off. When relay is off, the points are closed, the charger is connected to battery and relay is off. When we will reach at 13.4 volt, you can assign your own value at which level you want to disconnect it. At 13.4 volt, yes, 13.4 volt, the relay is now turned on, and now the relay will remain on because we made conditional statements in the Arduino code. Now when the battery level will reach again at 9 volt, at that time the relay will turn off. When it will turn off, it will connect the charger again. Let's see it. We can see at 9.2 volt the relay is still on. Now the relay will disconnect. When it is disconnected, it will close the points, so it will start charging. When it is now charging again at 13.4 volt, it will display that the relay is on. So let's start to write the code. Friends, welcome back to my channel. I received this comment on my video number 698 for battery overcharge protection. I demonstrated how we can write a code for this overvoltage protection. That was just only protection. In that circuit, it was disconnecting the battery at 13.4 volt. But this comment, Saber Smira. My viewer says that I have small remarks, sir. If we put a gap interval for 2 volt for charging and discharging the battery, for example, if we use two values to charge and discharge, we have 12 volt battery. This is our battery. We want to control the charging and discharging. We will put a relay here. This is our positive line and this is the ground line. We have two lines here. From the battery terminal, from this point, we will need a sense line. We will monitor this voltage. What is the voltage value here? And we will make condition. We have different conditions. The first condition, that when the battery is totally discharged, we can say it is condition number 0. When the battery voltage is less than 12 volt. This is our one condition. The second condition, that when the battery will turn on, battery is equal to 13.2 volt. We will say 13.4 volt. That's good. We will put this value. Now the battery is charged and here the relay will remain off, so that it will close, relay off, and here the relay will on. This is the second condition. Then the next condition, that the battery is charged and recently it is disconnected. So battery is less than 13.4 volt and it is now disconnected. This is our second condition. So now we want to remain in this condition until the battery voltage, that is the discharge level, we can say we will cut it at 8 volt. When this condition is valid, the relay will remain on. When it will reach at this condition, at that time it will go back to condition 0. This is our process. When the battery is less than 8 volt, it will reach back to battery management 0. When battery is less than 13 volt, or we can say it is empty, it will start charging. Relay will remain off. When it will reach at 13.4 volt, relay will on. When it is on, it will disconnect, and it will remain disconnected when the voltage are 13.4 volt to 8 volt. When it will reach at 8 volt, again it will go to the reset condition. So let's start. I will add the LCD 1602 16 by 2, 16 characters, columns, 16 columns and 2 rows. It is I2C bus module LCD, and I am using Arduino Uno. It is using Atmega 328 IC. You can write the code for Atmega 328 IC, or you can write the code for this Arduino and you can pull out this IC and you can use in your own project instead of using all the board. To monitor this battery, because the maximum limit here, that is 5 volt input. For that purpose we will use a resistor network, that is voltage divider network. It is 4.7K and it is 2.2K. We will connect this one to here, battery management system, and this one we will connect to the Arduino. For example, I will use to the analog input, that is A0. We can connect to any one pin. When we are using I2C LCD, at that time we will not use A4 and A5. We can connect these two pins to the LCD, and we can connect the last two dedicated pins for the LCD. But when we are using analog function, it is better we must use A4 and A5, so that these pins will not allocated to any other thing. And we will make a decision pin, for example, to any pin 2, 3, 4, 5, 6, 8, 7, whatsoever. Output we will provide to resistor, LED and ground. I will use 330 ohm or 1K resistor to indicate the message on this LED. Here I am using 1 kilo ohm. You can use 330 ohms whatsoever. To simulate the battery, I am not using this resistor network, but this time I am using this 10 kilo ohm potentiometer. It is the same. If we are using this one, I am injecting the voltage instead of this voltage network. It will the same. If you will use this network, the result will exactly the same. So let's connect. I will take positive and ground volt from this Arduino power supply, that is ground and positive 5 volt. Yes, I will inject to this ground and positive rail, and we will connect the ground and the positive voltage of this LCD, and we will connect the SCL and SDA pin. SCL will come to pin A5, analog output number 5, and SDA data pin will come to A4. That's good. And I will use this potentiometer here so that we can simulate the battery. I will take positive voltage and I will put it to the rightmost pin of the potentiometer in this side, and I will connect the ground pin. I will take the ground side and I will connect to the leftmost pin of this potentiometer, and I will take the signal out, the center wiper arm, the slider arm. This is our output which we are connecting here. If we will use this voltage divider network, at that time we will connect this to, for example, A0 pin. I connected it here, and we will take output from this board and we will connect this LED small pin we will connect to the ground, so that it will indicate the signal, and we will connect 1 kilo ohm resistor. It is better to use 1 kilo ohm, so the light will dim, but it is safe. We can connect to any one pin. Okay, I am connecting to 9 number pin, no problem. So our set is now ready. Output is digital IO pin number 9, and this is A0, and we connected I2C LCD, I2C liquid crystal display with Arduino Uno. Let's open the Arduino IDE. In the top we will write comment battery charging and discharging control. Okay, this is my comment. This for just only indication that we are building this project. Okay, now what we want to do now. The first condition, we want to configure the LCD. For that purpose, we will write here sketch include library, and we will add liquid crystal I2C library. Okay, I included this LCD. Now we want to include wire H. Include wire.h. Okay, we included these two libraries. Now we will copy this name, complete name, liquid crystal I2C. We will name it in our program LCD, and it is 0/27. This is its listen address at I2C protocol, and it is 16 colon and 2 row LCD, and put the terminator. This is our definition for this LCD, that we are using this LCD. Okay, we configured the LCD. Now we will cut it and we will paste it in the top. Yes, now we included library, and now we want to name these things. A0, what is A0? We will say it is battery level. We will rename this pin as a battery level. So here integer BTV LVL is equal to A0 terminated. Write the comment battery level monitoring using 4.7K and 2.2 kilo ohm resistor. Yes, that's nice. Okay, now we will define the role of this pin, battery level. Copy this name and come to here, void setup, pin mode. What is this pin? Pin mode, comma, write the name of this pin and type here input pin. This is our input pin. Okay, that's good. Now how we will deal with this pin? Now we said that there is a pin, there is a function that is battery level. We will copy this function and we defined the pin role of this pin, that is battery level input pin. Now we want to measure the voltage. We will put integer here, battery voltage. This is a name for our calculation. What is this? It is equal to analog read which pin? This pin, terminated. We set this buffer or this name, this value will equal to what is the present value at the battery voltage. Now float, calculate it. Float battery level, what is the battery level? That is equal to, make a calculation, when we apply 5 volt to the input, at that time it will convert it into 1024 bits. That will equal to 1023, because 00 is also included here. So we will say 5.0 divided with 1023, multiply it with this value which we measured from the battery terminal. Terminate. We calculated the voltage. Now one thing to understand, that when we connected this battery, we connected to a voltage divider network. What is the ratio between this voltage divider network and what are the voltage here? So if we divide the maximum voltage here, which are present 13.4 volt at that time, what will the voltage here? Okay, so its ratio will become 3. The total value, total voltage divided by this, what is the value? Multiply it here. So now we will say battery level, the new condition, it is equal to battery level multiply with 3.005. This is the equation, that how much voltage will there when we will multiply with 3.005, it will equal to this voltage. You can watch my last video to calculate it. The video number is displayed on the screen. Now we measured the voltage where we want to display. We want to display on the LCD. So in the setup, type here LCD.init, initialize. It will initialize the LCD. LCD.backlight, turn the backlight on for the LCD, and LCD set cursor to the top row and the leftmost digit. Now LCD set cursor, copy it here again, and now we want to print this message on LCD. LCD print. What we want to print? We want to display something before the voltage. If we display any voltage value without any marker, that will not good. We will say it is battery voltage or battery or voltage whatsoever. So we will put it inverted commas, BATT, battery voltage is equal to, this will give us some good look. Terminate it. Now LCD dot print. What it will print now? It will print this battery voltage, the new value, which is in the buffer which we calculated. Terminate it. So this is our program. I am not adding the nodes. This is just only because I am explaining it. So let's upload. Compile and upload. LCD set cursor 0, 0. Oh sorry, here I did not edit. Now we added the location and now it will upload. LCD set cursor 0, 0. Yes. Now it is uploading the program. Yes, the program is uploaded now. So it is showing 0.003 volt. If I will increase, yes, wonderful. Now it is measuring the voltage. When I will set to maximum, it will say 15 volt because I am feeding 5 volt. When I will move fully right clockwise, I will feed 5 volt to this pin. When I will set to counterclockwise, so we can say we are monitoring the battery voltage very nicely. Now we want to add condition. That is battery management condition. And now we want to integrate the LED. LED we connected to pin number 9. In the integer, in the top, we will say integer, we will say charge relay control, that is pin number, digital IO pin number 9 column. Now we will assign the role for this pin. In the setup, pin mode, comma output. This is our output pin. We defined the role that it will control the output relay. Now come to this section now. Because we measured the battery voltage, now we want to add some battery management system condition. So we will define a function here, integer, we will say BMS condition terminator. We assigned a function and we will say in the setup, come to setup and define here BMS is equal to 0. This is the predefined value here. When the system will start, at the initial startup, it will pick the value that the battery is less than 13.4 volts. We want to say here if the BMS is equal to 0. Now our conditional statement is starting. We will write a comment here, BMS 0, battery is less than 13.4 volts. This is our first condition. If BMS is equal to 0, which we defined here that at initial startup the BMS must be considered 0, and the second condition double AND, that is that battery level is less than 13.4 volts. What it will do? At that time it will write to this LED that the relay must be remained off. Digital write where, that is our relay control. Relay control LED must be low. This is our one condition. So at that time it will not do anything. Now we will put the second condition. When BMS, battery management system, condition 0 and battery is charged at 13.4 volts, what to do now? We will copy this statement. If BMS is 0, the first condition, what it will do, the battery is charged now and the voltage are greater than, this time the battery management system is 0 and battery level is greater than 13.4 volt. At that time it will need to turn on the relay. It will turn on the relay. This is now protection. Let's upload it. When the voltage will reach at 13.4 volt, at that time it must turn on this LED. Now I am increasing the voltage that the battery is charging now. At 5.4 volt the LED is off. 9 volt, 10 volt, 13 point, yes, at 13.6 volt we can see the LED is on. Yes, But now when the voltage are dropping, LED is off, so it will start charging again. We don't want to charge, discharge. When the battery is charged at 13.4 volt, at that time the relay must be disconnected, so the battery will go in discharge mode. So let's now provide condition here. Here we want to add one condition: BMS is equal to 1. When the battery is charged, we will say the condition is now 1. Battery management system is now 1. That battery is charged. We will add new comment here. BMS 1, that the battery is charged as we defined the battery is charged at 13.4 volt. This is the condition, and now it will remain on. Battery is less than 13.4 volt. We will copy this statement. We will copy this block here. Now we want to change the condition here. The battery is charged and battery level is now less than. Now the relay must on. This is now condition number 2. This was our first condition, that the relay was on. Now when the relay is on, battery is charged. It is indicating that the battery is charged. Now we said battery is charged and it is less than 13.4 volt. So it will keep the relay on. Let's upload it. Now when the battery will charge, yes, battery is charged now. It is not turning off. We can see the voltage are now less, but it will not charge. Now the battery is disconnected. Now we want to add another condition here. Next block, BMS2. In this block we will say battery management system condition number 2, that battery is reached at 8 volt or any voltage level, whatever you want. If you want to cut it at 7 volt, if you want to cut it at 10 volt, we will try different conditions. Let's copy this statement here. Now we will say the battery condition is now in the second condition, that is this one. We said battery is charged and less than 3 volt. Now we will define the condition here. BMS is 2 and the voltage, here you will add whatever voltage you want, 8 volt. Now digital write. Now what we want to do, because the battery is dropped now, turn off the relay. So type here low and BMS must be returned back to 0. Yes, now that's good. When the battery will reach less than 8 volt, at that time it will reset to this condition. So let's upload it. Now this is our first condition. Battery is discharged. Relay is now off and charger is connected to the battery and voltage are passing to the battery and it is charging. The level is increasing now and we are monitoring the voltage from this Arduino, and now the battery voltage are increasing up. 2 volt, 3 volt, and the still relay is off. 8 volt relay is off. 11, 12, 13. Yes, 13.4 volt. The relay is now turned on. So it will disconnect the battery. Now I will reduce the voltage now 12.6 volt because our this condition is now valid, that the battery is charged and it is less than 13.4 volt. So it is now on. At 8 volt, because we declared 8 volt. Yes, when it is 7.99 volt, the relay turned off and it started to charge the battery again. Wonderful. Yes, now again condition 0 is valid. It will charge, and when it will reach at 13.4 volt, yes, excellent. Now we will drop the voltage at 8 volt again. Nice. If I want to set it at 4 volt, suppose, just you will change the values here. I connected 4 volt. Now I added 4 volt, so the lower level, so battery will charge at 12 volt, at 13.4 volt and 4 volt. This is now our charging and discharging window. We can see the battery is now 0. This is our first condition. BMS is 0, voltage are less than 13.4 volt. Now battery is charging. When we will reach at 13.4 volt, 13.3847, yes, it is now charged. We can display some message here as well. But now when the battery is discharging, because relay is on, it is disconnected. 6.7. Before this at 8 volt it was disconnecting, but now 5 volt. Yes. Oh wow, excellent. If the video is good, hit the like button. Now I will change it to 9 volt. 9 volt. I will add the link of this code in the video description. You can download it. You can use as per your requirement. So it is a sample circuit. Yes, wonderful. At 13.6 volt, this circuit is now turning on this relay and battery is disconnected. At 9 volt, it will charge again. At 13.4 volt, the battery is disconnected. Again discharging at 9 volt. Nice. I hope so you enjoyed this video. If the video is good, hit the like button. If you have any question, let me know in the comment box. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.